Dr. Duncan is served a cup of coffee at 175 degrees Fahrenheit, but he prefers to drink at the temperature of 162, so he waits for 2 minutes. Let's make a timeline for this. Okay, so initially the temperature of the coffee was 175. So he wants to drink at the temperature of 162. So he waits 2 minutes and finds that the temperature of the coffee is 167. So after 2 minutes, the temperature is 167. So let's say this is initial temperature T at 0, and this is temperature after 2 minutes. If the temperature of the room where he is sitting is 70 degrees, that's the temperature of the medium, okay, which is constant all the time, 70 degrees. How long does he have to wait? So he wants to have the temperature of 162. So how long does he have to wait? What is the time? This is temperature is 162. So we want to find the time. Okay, so based on previous two temperatures, because the coffee was served at 175, after 2 minutes the temperature was 167. So from these two temperatures we can find at which the coffee is cooling. Okay, we want to find the constant K, and we know that from the Newton's law of cooling formula, the temperature T at any time T is given by Tm plus T naught minus Tm times quantity e raised to negative kt, and the temperature after 2 minutes is 167. Temperature of the medium is 70 plus initial 175 minus 70 e raised to negative k times t. That happens after 2 minutes. To subtract 70 from both sides, 160 minus 70, you get 97 equals 175 minus 70. Okay, that's 105 times e raised to negative 2k. Divide by 105, 97 over 105 is e raised to negative 2k. Take natural log of both sides. I'm going to write this in the right hand side. Take natural log, negative 2k equals natural log of 97 over 105. Now divide by negative 2, you get k equals negative 1/2 natural log of 97 over 105. Okay, you can go for decimals, okay, but make sure you write at least 4 digits after decimal. Now we want to find the time when to get to the temperature of 162 degrees. Okay, again we want to start from T naught, because we said T naught equals 175. Same formula, T is Tm plus T naught minus Tm times quantity e raised to negative kt. The temperature is 162 and the medium temperature here 70 plus T naught is 175. By the way, for this question we can now assume this as T naught as well. Okay, we could have assumed T naught and just find the time. Now since we used 175, the time we find here will be from the beginning. Okay, 70 plus T naught is 175 minus 70 e raised to negative k. K is already found, by the way, times t to be determined. 162 minus 70, subtract 70, you get 92. Subtract this 105 e raised to negative kt, divide by 105 e raised to negative kt. Pretty much the same, okay, both ways. Take natural log of both sides. I'm going to write this in the right hand side. So negative kt equals natural log of 92 over 105. Now divide by negative k, and the value of k is here, so negative k is just without negative. So t equals negative 1 over k when we divide by negative k of natural log 92 over 105. Now use your calculator. Okay, just -1 over k. K is the whole thing. Times natural log of 92 over 105, and you get 3.34, about 3.34. So he needs to wait for 3.34 minutes from the very beginning, because we use t0 to be the very beginning, and 2 minutes is already passed. So he needs to wait for subtract 2 from this, 1.34 more minutes. So he needs to wait for 1.34 minutes more, so that he can start drinking in his favorite temperature. More